Right now, there is a rock in space with Earth's name on it. Scientists know it exists. They know roughly where it's going. They've been tracking it for years, and for a brief, terrifying window of time, they genuinely weren't sure it was going to miss us. This isn't science fiction. This isn't a movie plot. This is a real object with a real trajectory and a real probability, however small, of impact. And the conversation around it reveals something most people don't know: how close we actually are, all the time, to the kind of event that ended the dinosaurs. We live on a planet that has been hit thousands of times. The craters are everywhere, if you know where to look. The difference between us and the dinosaurs isn't that we're luckier. It's that we can see what's coming. And right now, we're looking at something that's coming. So let's talk about it honestly. What it is, how real the risk is, what we've done about it, and what we'd do if the number got worse instead of better. I follow planetary defense science closely. The missions, the tracking data, the international frameworks being built right now to deal with exactly this kind of threat. And I want to give you the real picture. Not panic, not dismissal, just the actual facts, in the right order, so you can understand what's genuinely happening up there. Here's the plan. First, we'll talk about the specific object that has scientists most focused right now. Then we'll zoom out and explain just how many near-Earth objects are actually out there. After that, we'll cover what happened the last time something significant hit, because it wasn't that long ago. Then we'll get into what humanity has actually done to prepare. And finally, the part that should either comfort you or unsettle you, depending on your disposition. What we would actually do if the answer changed. Let's start with the object itself. Its name is 99942 Apophis, named after the Egyptian god of chaos. And for a brief period after its discovery in 2004, it earned that name. Early orbital calculations suggested it had a roughly 2.7% chance of striking Earth in 2029. That is not a rounding error. That is not noise in the data. A nearly 1 in 37 chance of a city killer, or worse, hitting the planet is the kind of number that puts planetary scientists in emergency meetings. It was the highest impact probability ever calculated for a known near-Earth object of its size. Apophis is about 370 meters across. For context, the asteroid that created Meteor Crater in Arizona, a bowl nearly 1.2 kilometers wide and 170 meters deep, was roughly 50 meters across. Apophis is more than 7 times larger. An impact would not be an extinction event, but it would be catastrophic. The blast would be equivalent to hundreds of nuclear weapons. It would level everything within a massive radius. If it hit an ocean, the tsunamis would be devastating for coastlines across entire ocean basins. More observations were gathered. The probability was recalculated, and the 2029 threat was eventually ruled out. Apophis will pass Earth on April 13, 2029, at a distance of just 31,000 kilometers. That is closer than many of our own satellites. Close enough that it will be visible to the naked eye, moving across the sky. People will be able to watch it from their back gardens. No telescope needed. But the story doesn't end there, because after 2029, Apophis will be gravitationally nudged by Earth's pull. And depending on exactly how close it passes, down to a margin scientists call a keyhole, its new trajectory could set up a secondary impact possibility in 2036 or 2068. For years, those secondary windows kept the scientific community watching very carefully. Then, in 2021, NASA's WISE telescope and ground-based radar observations refined the trajectory further. The verdict: Apophis is not going to hit Earth in 2029, 2036, or 2068. The probability of impact in the next century has been reduced to effectively zero. That is genuinely good news. But here is the thing. Apophis didn't go away. It's still out there. It will still pass closer to Earth in 2029 than any object of its size in recorded history. And there are thousands more where it came from. Right now, NASA's Center for Near-Earth Object Studies tracks over 2,300 objects classified as potentially hazardous asteroids. These are objects larger than 140 meters that come within a certain orbital distance of Earth. Over 2,300, and that's only the ones we've found. Estimates suggest we've cataloged perhaps 40% of the near-Earth asteroids large enough to cause regional or continental devastation. The others are still out there, untracked, unnamed, moving. And we know from history what happens when something gets through. On June 30th, 1908, something entered Earth's atmosphere over a remote region of Siberia called Tunguska. It exploded in the air before it even hit the ground, what scientists call an airburst. The object was probably between 50 and 80 meters across, smaller than Apophis, much smaller. And yet, the blast flattened approximately 2,000 square kilometers of forest. Around 80 million trees knocked flat. The shockwave was felt hundreds of kilometers away. If it had hit a city, the death toll would have been enormous. More recently, February 15, 2013. A meteor entered the atmosphere over Chelyabinsk, Russia. It was only about 20 meters across. It exploded with the energy of about 30 Hiroshima bombs. The shockwave blew out windows across a huge area. Over 1,500 people were injured, mostly from flying glass. And here's the part that should wake you up. We did not see it coming at all. It was completely undetected before it hit. On the same day, a completely separate asteroid, 2012 DA14, about 30 meters wide, passed within 27,700 kilometers of Earth. Two separate objects on the same day. One hit, one missed. Neither was connected. It was just Tuesday. So what is humanity actually doing about this? More than most people know. In September 2022, NASA deliberately crashed a spacecraft into an asteroid. Not because it was a threat, but to test whether we could actually change an asteroid's trajectory. The mission was called DART, Double Asteroid Redirection Test. It targeted a small moonlet called Dimorphos, orbiting a larger asteroid called Didymos. The spacecraft hit Dimorphos at roughly 6.1 kilometers per second, and it worked. The impact shortened Dimorphos's orbital period by 33 minutes, significantly more than the minimum success threshold. Humanity, for the first time in history, deliberately and measurably changed the orbit of a celestial body. That is not a small thing. That is a species proving it can protect itself. But DART only works with years, ideally decades, of warning. The earlier you nudge an asteroid, the smaller the nudge needs to be. A tiny change in velocity years out becomes a massive change in position by the time the object reaches Earth. If you wait until it's close, you need something far more powerful. And right now, if a large asteroid were discovered on a confirmed impact trajectory with only months of warning, our options would be severely limited. That's the payoff. That's the real takeaway from all of this. We have the technology to deflect asteroids. DART proved it. But deflection requires time. The single most important thing in planetary defense is not rockets or nuclear devices, it's telescopes. Finding objects early, tracking them precisely, having years or decades to act. Every dollar spent on asteroid detection and tracking returns enormous value, because early warning is the difference between a manageable nudge and an unsurvivable timeline. Right now, NASA is building a new space telescope specifically for this purpose, the NEO Surveyor, designed to find 90% of near-Earth objects larger than 140 meters within a decade. It will detect objects that ground-based telescopes miss, especially those approaching from the direction of the Sun, where we currently have a significant blind spot. That blind spot is real. Chelyabinsk came from that direction. So did several other undetected objects. NEO Surveyor is designed to close it. Let's bring it all the way back. Apophis is real. It will pass Earth in 2029, closer than many satellites, visible to the naked eye. And it will not hit us. But it will remind every person on Earth that these objects are out there and they move through our neighborhood. More than 2,300 potentially hazardous asteroids have been cataloged, with many more yet to be found. Tunguska and Chelyabinsk proved that even small objects carry devastating energy. And Chelyabinsk proved we can be completely blindsided. DART proved we can change an asteroid's orbit. And early detection, not weapons, not last-minute solutions, is the real foundation of planetary defense. We are not helpless, but we are not done either. Now I want to hear from you. Which part of this landed hardest? Was it the Apophis probability in 2004, the Chelyabinsk blind spot, or the idea that DART, a spacecraft the size of a vending machine, actually moved an asteroid? Tell me in the comments. I read every one. Stay informed. The sky is worth watching. And now, more than ever, someone is watching it for you.